Welcome back to our channel Storm Rider. In this video, we're diving into an in-depth, highly technical breakdown of the 2026 CF-18 Hornet, a comprehensively modernized variant of Canada's long-serving multirole fighter. Even though the original CF-18 entered service decades ago, the 2026 upgrade transforms it into a remarkably capable machine by integrating advanced avionics, extended life structural enhancements, and next-generation sensor technology. The result is a fighter that may not be fifth generation, but absolutely refuses to be left behind. Today, we're going to explore the engineering side, the systems, the aerodynamic changes, and the mission capability improvements that define this upgraded aircraft, all in a clear and understandable way. Let's begin with the airframe, because the 2026 CF-18's upgrades start deep inside its structure. Over years of operations, CF-18's accumulated significant fatigue due to high-G maneuvering, carrier-derived design stresses, and the harsh climate conditions common in Canadian missions. The 2026 Structural Extension Program focuses heavily on fatigue life improvement. This includes the replacement or reinforcement of key load-bearing components such as wing root ribs, fuselage bulkheads, horizontal stabilizer mounts, and sections of the center barrel, one of the most stressed parts of the Hornet. Engineers incorporated a greater percentage of carbon fiber composite elements into outer skin panels and control surfaces, reducing overall structural weight while improving stiffness. These refinements help maintain aerodynamic stability during high AOA maneuvers and delay the onset of aerodynamic flutter at elevated speeds. Moving deeper, the 2026 CF-18 benefits from enhanced corrosion-resistant alloys in regions exposed to moisture, ice, and de-icer fluids, particularly around landing gear wells, avionics bays, and engine inlets. These upgrades significantly reduce long-term maintenance burdens and improve mission readiness rates. While these structural adjustments aren't visually dramatic, they're critical for keeping the jet airworthy through the transition phase toward next-generation fleet replacements. Now that the backbone of the aircraft is stronger, let's move to the engines. The 2026 CF-18 continues to use evolved variants of the F404GE series engines, but with improved hot section materials and more efficient digital engine control software. The upgraded turbines incorporate advanced single-crystal alloys and improved cooling pathways, enabling the engine to operate at higher temperatures without degrading lifespan. The FADEX software update refines throttle response timing, increasing the engine's ability to deliver power smoothly during dogfight maneuvering or tight interception turns. While these updates don't dramatically increase maximum thrust, they improve engine reliability, reduce fuel burn at cruise, and extend time between overhauls. Furthermore, the redesigned exhaust and nozzle components improve thermal distribution, which supports both engine health and slightly reduces the IR signature. It's not stealth-level IR suppression, but every reduction matters during modern beyond visual range engagements. Now let's shift to one of the biggest leaps, the avionics. The cockpit transformation is one of the most noticeable elements of the 2026 CF-18. Earlier analog-digital hybrid layouts have been replaced by a fully modernized glass cockpit featuring wide-area LCD panels. These screens support multi-layer data overlays, tactical symbology, and mission-specific page configurations. Pilots can now reassign display zones more efficiently, for instance, placing radar data on one quadrant, targeting information on another, and navigation overlays across the bottom segment. The improved software architecture shortens data refresh cycles, meaning the pilot sees changes and updates almost instantly, a key requirement for modern engagements where milliseconds matter. A major addition is the advanced sensor fusion processor. Earlier CF-18 systems required pilots to manually interpret radar returns, IR warnings, data link information, and threat cues separately. The new processor integrates this data into a single coherent picture, drastically reducing workload. Instead of switching between pages to determine if a distant radar contact is hostile, unknown, or friendly, the system automatically categorizes it using available data link feeds, identification protocols, and signal patterns. This doesn't replicate the full fusion seen in fifth-generation jets, but it comes impressively close given the airframe's age. At the heart of this integration lies the AESA radar upgrade. The 2026 CF-18 moves to an advanced electronically scanned array, replacing older mechanically scanned units with a fixed panel architecture that electronically steers its beams. This allows nearly instantaneous tracking shifts, multiple simultaneous target locks, and improved low observability detection capability. The AESA's resistance to electronic jamming is significantly stronger, thanks to frequency agility, lower sidolobes, and advanced waveform shaping. It also expands ground mapping and synthetic aperture imaging modes, letting the CF-18 gather highly detailed terrain images even through moderate weather. This is essential for reconnaissance support and precision targeting. Alongside radar improvements comes the revamped electronic warfare suite. The defensive system now features more advanced radar warning receivers with higher sensitivity, enabling earlier detection of hostile emitters. The digital signal processing algorithms allow the aircraft to distinguish between radar types, such as differentiating between fire control radars, tracking radars, and search radars, which dramatically increases survivability. Countermeasure deployment modules have also been upgraded, giving the system more intelligent flare and chaff release patterns coordinated with incoming threat angles. Next, let's take a look at aerodynamics and flight control enhancements. The 2026 CF-18 still relies on its classic aerodynamic profile. The leading-edge extensions, twin tails, and large wing area combine to deliver the exceptional handling the Hornet has always been known for. The upgrade package fine-tunes the flight control computer with new control laws. These adjustments improve stability during high angle of attack flight, increasing the jet's resistance to yaw departures and reducing oscillations during tight turns. Engineers also recalibrated control surface responses to compensate for the slightly different airflow characteristics created by new composite panels and structural adjustments. Even though the jet isn't pushing new top speed records, its acceleration consistency and turning reliability see meaningful improvements due to these flight control refinements. Pilots often describe the upgraded flight model as smoother, more predictable, and more confidence-inspiring, particularly during complex engagements. Let's explore the communication and data networking additions, which are critical for modern warfare. The 2026 CF-18 integrates improved Link 16 capabilities, allowing it to exchange secure encrypted data more quickly. This is essential for coordinating intercept missions, relaying target information to allied aircraft, and maintaining situational awareness in multi-jet formations. The upgraded communication suite also includes advanced anti-jamming protection and improved satellite communication capability, enabling stable long-distance data transmission. A major improvement, although less visually noticeable, is the aircraft's upgraded mission computer architecture. The new processors handle significantly higher data throughput, allowing near real-time conversion of raw sensor information into actionable displays. This not only speeds up pilot decision-making but also keeps the jet responsive to emerging threats and tactical shifts. Turning now to payload and mission capability, the 2026 CF-18 retains the classic Hornet strengths: flexibility, broad compatibility with established weapon systems, and strong performance in both air-to-air and air-to-ground missions. Hardpoints remain structurally unchanged, but wiring and munition interface software have been upgraded to support more advanced targeting pods, modern precision-guided weapons, and enhanced identification systems. Updates in the store's management system improve weapon release accuracy and safety protocols, ensuring reliable performance even during high-G maneuvers. The jet's targeting pod integration is particularly important. The 2026 version supports updated pod generations featuring higher resolution infrared sensors, improved laser designators, and better stabilization algorithms. This allows pilots to identify targets more quickly, track them more stably, and engage with more confidence at extended ranges. Let's also break down the canopy and visibility improvements. While the canopy design remains familiar, the 2026 upgrade introduces revised optical coatings that reduce glare, block harmful UV more effectively, and improve clarity in glare-heavy environments such as snow or water. The increased clarity is especially useful during low-altitude patrol missions in northern regions, where reflections and extreme brightness can hinder visibility. Lighting systems also receive substantial updates. The new LED-based formation and navigation lights reduce electrical load, improve visibility, and last significantly longer. This small improvement actually contributes meaningfully to maintenance efficiency, especially in operations involving frequent night sorties. Another vital aspect is maintenance and diagnostics. One of the most practical improvements introduced in the 2026 model is the expanded use of onboard self-diagnostic systems. The upgraded computers constantly monitor vibration patterns, temperature variations, hydraulic pressure fluctuations, and structural stress signatures in key components. When anomalies are detected, the system logs them automatically and provides technicians with predictive maintenance recommendations rather than relying only on scheduled inspections. This significantly reduces unexpected failures and increases flight availability. As for unique selling points, the 2026 CF-18's most compelling strength lies in how well it blends legacy capability with modern enhancements. It offers a level of agility, reliability, and mission flexibility that remains impressive even as next-generation jets join global fleets. While it may not compete with stealth platforms in signature management or deep fusion, it excels in cost-effective readiness, pilot-friendly handling, and dependable multirole performance. Everything together makes the 2026 CF-18 Hornet a fascinating example of how smart engineering, thoughtful modernization, and powerful software upgrades can breathe new life into a proven platform. It may represent the final era of the Hornet in Canadian service, but it does so with remarkable capability and relevance, standing as a testament to decades of aviation evolution and adaptation.